This is the SolidWorks CSWPA sheet metal demo test. So we're just going to walk through this. This should be pretty quick. Alright, so we have some variables. I went ahead and started up SolidWorks here and put the variables in for us, save some time. So we've got A, B, C, and D, and then we've got some holes to punch through this, including this oblong looking hole here. First question is design this part in SolidWorks, this sheet metal part. And we're using 1060, of course. Okay, a couple of things to pay attention to is our sheet metal thickness and our inner bend radius here. Trim side bends, we can set that on. Pretty easy to find there in the settings, but it's not giving a K factor, so we're going to assume it's just 0.5. So let's get started. First thing we need to do is let's set our base. Easiest way to do this is, if it's going to work out for us, we'll set a center square like this, center rectangle. We'll set this equal to the B variable. Okay. Set this equal to the A variable. Next, we go to our sheet metal tab here, and again, if that's not there, right click, go to the tabs, and enable that there. Select the base flange / tab. Then we need to set our dimension for the depth. So in this case, we're looking at 1.20. It's already set for me 1.2, but make sure you override that if it's not set. K factor, again, I quickly looked through this and just checked, and there is not a K factor until a couple questions down, so we're going to assume it's 0.5. It does not specify auto relief, so we'll leave that as is. Hit the checkbox, and we have our base. And while we're at it, let's go ahead and set our material here to 1060. Rebuild, and we should have that number 5832. And then we'll keep going. So probably going to do a virtual edge just to keep our dimensions straightforward here. And when probably the best approach is to put the sidewalls up and then do the 3 end tabs just to make things easier for fitting in these, I guess you could call it like a mitered edge. And we have a 0.5 gap between these where these bends come, so those cuts need to be accounted for. So to do that, we're going to use an edge flange. We'll select this edge right here. Set something arbitrary for now to start. Then go to here, and we're going to set our total height to that C variable, because in this it's setting the height to C for those 2 edges. And then what we want to do is use this type right here, bend from virtual sharp. That'll keep our dimensions tight to the A and B values. And then down here a little bit should be an option that says trim side bends, so we'll go ahead and enable that as well. We don't need to edit the flange profile, so we're good to go there. And everything else should be good. Before we get any farther, let's make sure that we have our standard bend radius. It says 1 millimeter, but we'll check that real fast. We have a master bend radius up here on our sheet metal. If we look at this property, this right here is our master bend radius, our master thickness, and as well as our K factor and relief settings. And this is like a global variables for this sheet metal part that you're making. Now that we've got the sidewalls put in, let's kick up these almost like a tab on the end here, and the D is going to be the depth for these. So I'll start up a flange again, and we're going to go here. Again, we set something arbitrary for the time being, and then we just override that with our global variable setting of D. Now I can come back in, do this, And we can actually do this edges as well. So here's our gap. It says the D right here at the gap distance. That is specified at 0.5. So let's set that to the proper value, 0.5. And depending on how, when you selected the trim side bends, that should be selected again and ready to go for you. We'll prove that. So now we have the basic shape. Now what we need to do is push these holes through both sides, and since we've got looks like holes all the way through, it says 6 exit 4 diameter, 4mm diameter, so we can make this easy. Just use a plane. Let's go ahead and set these holes. $4mm. Make 3 of these all equal. I believe they made this pretty straightforward. 9 from the outside on all. Yep. 9 from the inside, and then 10 down for these two. 50 from the outside, so that's centered because half of 100 is 50. But, well, we'll maintain that anyway. We'll set that. So let's go ahead and break that relationship just to make sure it's going to do what it's supposed to do. So that's 50 from this edge. And then 9 from the bottom. And these are 9 from the outside edge. 10 from the top. Set the 9 from here. Then we can set these to be vertical to each other. Sorry, horizontal. So now we've got 3 options there for doing a cut. Go ahead and do these throughout both, and we've got our holes. The last thing it's asking us to do is put this cut out. Pretty straightforward. I'll just use a, go ahead and start here on one of the planes. Normal to that, let's do ISO and then make sure that we're good. So we're going to do over here. Let's first create a center line. Then we'll do mirror entities for that. Let's look at the dimensions here. 40 tall, 30 in that little part, a couple of triangles. And I'm seeing a redundant dimension here. This is going to be over-defining if we put that 2.5, but it's whatever. So 30 from an edge, 30 from that outside edge, and we'll go ahead and do that. Okay. So that's 30 from the bottom. I think it said inside edge, outside edge. All right. I'll draw these in. Yeah, good. Okay. What's next? Okay, 20 on the outside. Then 15 in this section right here. I believe that was 5. Yep. are fully defined, and we can go ahead and do an extruded cut. We can just do up to next since we're doing from the plane. Okay. I believe that's it for question 1. Let's just check our variables real quick. 180, 150, and 15. 180, 150, 15. I have the cheat sheet up here. So our mass is supposed to be 125.60, and they give a tolerance of 0.5, 125.60 plus or minus 50. And we nailed it. Right on the money. Question 1, done. Question 2, update parameters of the initial part. Nothing has changed in the settings. And measure again. That's pretty straightforward. That's why we use equations. 200, 110, 40, 18. Rebuild for good measure. So that should be doing it. 133.37. Nailed it again. All right. On to question 3. Use images. So it looks like they're measuring this, flattening the part out. Okay. Now we're updating our K factor 2.4. Everything else stays the same, but we need to update our variables. First was 180. Then 100. 50. 15. To update that K value, we're going to go to our sheet metal feature here. Go to properties for editing the feature. Then we'll set that right there. And we're asking to go to 0.40. So we'll set that to 0.40. Approve that change. Alright, now it's asking us to measure distance X, which is going to be this shorter side of it flattened out. So let's go ahead and flatten this out. It's asking for that line right there, which is 195.85. 195.85. So far doing great. Right? On to part 4. Now it's updating K factor again. Yep. Alright, they're updating the variables. So let's jump into those. 110. 40. 18. It's also asking us to update the K factor to 0.32. Again, right click here, go to your edit feature for the properties for the sheet metal. Change that to 0.32. Approve the change. And it's asking us to measure distance X again, which is the same distance right here. Okay. Just touch this, look at the bottom right. We've got length 185.55. 185.55. Alright. Doing good. Question 5. So now it's saying, using the same everything, measure the bounding box. So to get to the bounding box, we need to get to our cut list right here. Expand this, expand that. If it hasn't built yet, you may need to check the Update Automatically button, checkbox there, and then click on Update. Otherwise, we can just go here and go to Properties. Okay, expand this just a little bit to make it easier to see. And what's asking us is measure the bounding box area. So in theory, you could actually take the length and the width here of the part and multiply them together, but let's go ahead and look at this. Bounding box area. 42,963.25. 42,963.25 plus or minus 100. So the area is going to be that value times that value. So just for giggles, if you guys want to see this, here's my calculator. Okay, we're going to multiply 185.55. We're going to multiply that by our width, which gives us our area. So it's going to be 231.55. Okay. I don't know if you remember that, but 42963 plus or minus. So add a little bit to this, but that's the idea. But for the accuracy, the sake of accuracy, if you go here, go to Properties, it's a couple, like usually it's third and fourth one down. That's what the answer they're looking for. Last question is to create, it looks like a hem. Okay, pose and create two symmetrical bends to the interior. It's not giving us a couple things though. It's kind of hard to see. Those are interior bends on those hems, really hard to see. So if we zoom in big time, I'm able to see that hem right there a little bit better. And then we've got to edit the profile of the hem because we're not going all the way to the edge. And it's telling us 10 from the top edge. Doesn't look like it's cut, but it's considered like a tear edge, but I'm not seeing any of the tears or the relief built into it, so we'll do it and we'll see how close we get just by default. Okay, so we're keeping the same parameters. K value has not changed, but now we need to accommodate these two hems. And it's saying that the hem gap distance is going to be 1. That's the distance between the inside and the outside of that actual hem. We're going 10 in deep-wise, and then I need to offset that profile by 2 on each side. So let's unflatten this. We'll just go ahead and pick a side, so we'll do this one first. Go to our hem option, which is right there. Okay, so here is the values we're going to need. So the top one is the length, and it's specified at 10. And then we're keeping the gap distance, which is specified here, the hem gap distance right there, to 1. Okay, so that's in there, K factor, etc. And we're just going to leave it without everything else here. But you notice that's going to raise it up. So according to what I'm seeing, it needs to be in that position right there. If that makes sense, we're pushing down and in. But before we do that, we need to edit the width. And they're editing it because this profile sketch will come up. We're going to bring our ends in a little bit. I believe it's asking us to measure 2 in. Yep, 2 from the inside. Go ahead and grab our measure tool. Just measuring from the point to the edge there. And that should do it. That is not right. Let's take a look at the hem. All right. Okay. It's open, and we want that kind. Let's set our relief to Well, that might be okay. I'm gonna lie. Let's try this because it looks too clean in the picture there. I could be wrong though. Let's find out. Alright, now we're gonna do the same exact thing over here. Create him. Since we use the same information, it's already ready to go. And all we need to do is set our length. Go ahead and grab my dimension tool. Okay. So let's do the same thing for this. And that's that. We've got our hems in place. And I believe they're also asking us to delete the holes. So I'll just suppress those. And let's see what it's asking now. Asking for mass, I'm guessing. What is the mass of the part? Okay, that's good, that's good. Everything else is the same. Let's see how we did. 185.95. 185.13. That's pretty close, but not quite. Let's figure out what we did wrong here. Or if it has to do with the total length of these things. It should do it. K factor is going to be the same as it was here, 32, 200, 110. So those haven't changed, so make sure it goes good. 200, 110, 40, okay. Okay, let's change the hem type to be flush. Not sure how much that's going to change things. 138.20. Going to call that good. 138. We're within 0.7. Because it did not specify the relief on here. That's probably causing a little bit of the uncertainty. Remove round holes. Yep, we did that. Same. So, yeah, I think that's about it. Hopefully that's helpful for you for the test. A little bit quicker here, but if you have any questions, you know where to find me.